Did you do it? That's nice. All right. So I think you'll find yesterday was harder than today. At least I think that. So we are going to finish section day 1, or sorry, section 2.1, and do section 2.2 today. And it won't be that bad. So the first type of question that you're gonna see is they're gonna give you 2 or more, these are in function notation, okay? So when it says g of x, that's the same thing as if it said y equals. The x is just saying what variable they have. So here, h of x, don't worry about the h or the g. That x is just saying that's what variable that you have. Now, when they say g of 4, what that means is they want you to take this 4 and put it into that equation. Okay, so g of 4 would equal 3, and we would put it in for x. So we would put that 4 in for x, and then we would subtract 6. So all it is, when it says g of 4, you go to the g function and you put the 4 in for x, okay? And then 3 times 4 is 12. 12 minus 6 is 6. Okay. Then when it says g of -6, same thing. You would just put -6 in for x. So it'd be 3 times -6 minus 6. Well, 3 times -6 is -18. -18 minus 6 is a -24. Now, if you're not the best at multiplying and adding positives and negatives, you can punch this into your calculator exactly how it looks. And if we look at h of 2, that means we're going to go to the h function, and everywhere you see an x, you're going to put a 2. So you're going to put a 2 in here as well as here. So here we would go -3. In for x is 2, and we have to square just the 2. And then it would be -2, and in for x, again, you put a 2, and then +5. Now, on your calculator, you can punch this in exactly how it looks, okay? So if you went to your calculator and you went -3, parentheses, 2 parentheses squared. Now, honestly, with this being positive, you don't have to put it in parentheses. You could just go 2 squared. But I'm showing you that because if it's a negative, you want to put it in parentheses. So I'm just trying to be consistent there. And then if we go minus, it was 2 times 2 plus 1. 2 times 2 plus 5. Is that what I said? So -11. So you can just punch that right in your calculator. Does anyone need to come and get one? If you need to, the graphing ones and the regular ones. There's a graphing one on my desk too. All right, so now when you have h of -3, that does matter how you put that into your calculator. So when you put it in here, you want to put the -3 in parentheses. So this is going to look like this. You're going to have -3 just from the function. And then they want you to put -3 in for x, so it would be -3 squared. So if you look up here, the -3 is part of the function, and then I put -3 in here and I squared it. Then I would go -2 times the -3. So -2 times a -3, and then +5. So I would always be careful, especially when you have a negative, put it in parentheses, and then you can just punch that right into your calculator, right? So if we go to our calculator, we would go -3, and then what's going to change from this one to this one is just where you had the 2 in this case and this case is going to become a -3. Okay, so it'd be -3 parentheses, -3 parentheses squared, and then -2. And then for that -3, I would probably put it in parentheses. So I'd go parentheses -3, and then +5. Okay, and when we do that, we get -16. Is that what you guys got too? Yeah. So and you also can do it just kind of working the problem out too. But if you're good at punching it into your calculator, that's fine too. So now this one is where we use the h again. And whenever there's an x here, you have to put 3D in it. Now, when you're putting 3D in, that means you're going to have a D in your answer. You don't solve for the D or anything like that. So if I'm putting 3D in here, I'm going to have D's in my answer. So again, where there's a -3 up here, I'm going to get a 3D, and that's squared. And then here's the -3 again. We're going to put a 3D in there, +5. So if I look up here just to see what I did, where there was an X, I put parentheses and I put the 3D in there. And then here I put the 3D in there. Now, when there's that D, you can't punch that into your calculator, the whole thing. But you could punch this much into your calculator. You know, you could go -3 parentheses 3 squared, and you could figure out this term. When you do that, this would be -3 times 9. So that would be -27. And then this is just D squared. Okay. Then you have -2 times 3D. -2 times 3 is -6D. And then you have +5. And do you guys know you can't combine the D squared, the D, and the constant? So you just have to remember if they're having you put a variable in, you're going to have variables in your answer. Okay? So this whole thing is your answer. Okay? So that's one type of, that's kind of the ending of section 2.1. And now we're going to look at section 2.2 on linearity and symmetry. I don't think we do this one today. I think that one's in Monday. All right, so the first thing we're going to talk about in this section is how can you tell by looking at a function if it's linear or not? Linear just means that if you graphed it, it would be a straight line, okay? So there are some rules here that tell us how we can tell if something is a linear function or not. The first thing is, in that linear function, you can have an x and a y, but they can't be multiplied by each other. So what I mean by that is, say that you had 5 equals xy, okay? They can't be multiplied by each other, so this would not be a function, okay? The other thing is you can't have an x or a y in the denominator. So let's say that you had 5 over x plus y equals 10. That would not be a function because it has a variable in the denominator. Okay. Another thing you can't have is any of your x's or y's to an exponent. So if I had like y equals x squared plus 5, you guys remember what this should look like if it has an x squared? Remember we learned that yesterday? When we graph something like this, didn't it look like a parabola? So that would not be a line. Okay? That would be a curved line or a non-linear line. You can't have exponents with your x or y. The other thing you can't have is a variable under a square root or a cubed root or anything like that. So if you had 5 times the square root of x minus y equals 12, because that x is under the square root, we can't have that. Sometimes you'll see this too. Okay, where you'll have like x plus 5 under a square root. None of these are linear. Okay, and this one kind of talks, I talked about this already. X and y only can be to the first power. They can't be squared or cubed or anything like that. And no square roots of your variables. So if you look here, these are all examples of things that are linear and linear functions. Here, the x is just to the power 1, so that's good. Same here. You can have a fraction before your x, and you could have this. That would be fine because what's on the bottom of the denominator is a number. It's not a variable. And then here, your x and your y only have the power 1. This one, if you guys can read this, is 1 over x. And you can't have an x on the bottom. This one, if you can see it, this says 6y squared, and y can't be to a power other than 1. And then this one has x times y, and you can't have x and y multiplied together. Okay, so your first type of question in this part is going to give you some different functions. And you just have to say yes or no, whether it's a linear function or not, okay? So if I look at this one, what do you think? The x is on top, right? So is that okay? Yes, okay. The second one here, what do you think? No. And the reason would be what? We are gonna specify the reason. Why isn't that one? X on bottom. So we'll just say x on bottom. And if we look at 3, do you see how it's squared? Does that work? No. So we're going to just say no, and let's just say x squared, because we'll know that we can't have an x squared. How about 4? No, because it has a y squared. Remember, x and y can only be to the power of 1. What do you think about 5? That's okay, right? X and y both have a power of 1, so that was fine. How about 7 or 6? Sorry. We have an x on the bottom. No. So we're gonna say no X on bottom. Then 7, how about this? Is this okay? So let's just say no, and then let's just go X, Y. That's what's wrong. You can't have X times Y. This, can we have an X on the bottom? No. Nine, what do you think? You have something under the square root? No. You could have a number under the square root, you can't have a variable under the square root. So we can't have the square root of Y. If it was the square root of 19, that would be fine. And then here, notice we have this whole thing under the square root, so that X again is under the square root. So let's just say no, and let's just do that. Because then you'll know if there's an X under the square root. Okay? All right, so this is the second thing that we're gonna learn in this section. They're giving us 2 different scenarios. It says Melina and Lena worked part-time at a smoothie store. The number of hours they worked increased for the first 5 weeks of the job. So if you notice, they're increasing here. And then these are the weeks for Helena, and notice her numbers are increasing also. The graph models Melina's weekly earnings, and the table models Helena's weekly earnings for these 5 weeks. State whether each relation is a linear function. Okay, you look at this one, is this going to form a straight line? Yes. So this one is yes, it's a linear function. Okay. All right, now here, how you can tell if this would form a linear function or not? Do you see how these, each one goes up by 1? So what that means, because each of these go up by the same amount, that means each of these need to go up by the same amount. And from 60 to 120, that's going up 60. From 120 to 180 is going up 60. So it looks like it's working. But when you go from 180 to 210, that's only going up 30. And when you go 210 to 240, that's going up 30. So because these are not all where you add 60, just wanted to know. Now, if we look here, it says Shayla and her brother Malcolm both left home on their bikes at the same time. The graph shows a function modeling Malcolm's distance from home over time. So what must have happened here is Shayla went up, got 3 miles away from home, and then started going back home. That's what this is showing. And then it says state whether each is a linear function. This is not a straight line. This is 2 straight lines. So this is not a linear function. Okay, linear is just 1 straight line. Then this one is where you would look. Do these all increase by the same? This is adding 10 each time. And then you just have to make sure on the bottom, does it look like they're adding the same amount each time? Yeah, they're adding 1.5 each time. So that, because these all increase by the same and these all increase by the same, then yes, that is a linear function. Okay. Then the next thing that we're going to talk about is if something has line symmetry or not. So what that means is, could you draw a vertical line or a horizontal line so that if you folded that figure over the vertical or horizontal line, would the sides match up? Like kind of would the sides be a reflection of one another? And if you look at this parabola, parabolas are going to have line symmetry, and it's right here. Okay. Now, one of the things they're gonna do today is they're gonna have us write the equation of that line. And I don't know if you guys remember this, I think you had this in your notes, but if you ever have a vertical line, the equation of that line is x equals whatever the x is right there. And x is 1, 2, 3 over. So you would say, yes, it has line symmetry. And the equation of it is x equals 3. Okay. Then this one, if you're looking at, could I draw a line that would give me line symmetry? Again, it's here. This line doesn't, extend all the way, but if it did, it would look just like this. And when I folded it in half, both sides would map on each other. And this is x equals 1, 2, 3 also. This one is right down the center. So the way that you would write this one is, yes, again, it has line of symmetry. And you could either say x equals 0 because this line goes through at x equals 0. Or you could say the line of symmetry is your y-axis. So either of those would work because this is your y-axis. Now this one, there is no way that I could draw a line so that this side would map onto that side. Okay, so this one does not have line symmetry. So you're kind of thinking like, if I put this line here and I folded this in half, would this map onto that? And okay. Now, this one I actually think is a little bit more confusing when you talk about point symmetry. So what you're looking for with point symmetry is there a point? I'll show you on this one, this point is a point symmetry. And this is harder, three-dimensional things, and this actually isn't even three-dimensional, this is two-dimensional. Spatial things are harder for girls than it is for boys, just so you know. Especially when you get into three-dimensional things and you try turning I remember taking a Calc 3 class in college, and it was awful. And when I went to college way back in the day, it wasn't common for girls to be in math. And there was me and one other girl in all our classes, and we struggled so much more than the guys when it came to some of the graphing stuff. But what this is, when something has point symmetry, you want to think about if you took this figure and you turned it upside down, would this map onto this? Okay, so if you can envision that, if you took this figure and you turned it upside down, would this map onto this? And would this map onto this? Now, another way you can do it is you can look at this point and this point and kind of visualize a line drawn here. And you can kind of think, is this point the same distance from that as here? And then you could look at maybe this point and this point. Is this point the same distance as it is there? So that's another way you can look at it. Some people can just, like I struggle with this, but if I turn this upside down, that's hard for me to see. But so I kind of look at it here to here, that would map over. Here to here, that would map over. You get that? This one is, you want to think, if you took this and you turned it upside down, would it map onto itself? You get if you took this and you turned it upside down, this would come here and that would come there. See that? If I took this and I turned it upside down, it would come down here. And then if you looked like this point, would go down here. This one would go down here. So if you drew a straight line from here to here and you went down there, that's where that new one would be. So it's like you're taking that figure and you're turning it upside down. So this does not have points in it because it creates a new figure. It's not going to map onto itself, whereas this one, if you turn this upside down, it's going to look just like it did. Okay. So let's look at these. So this is asking us, does it have line of symmetry? Does it have point symmetry or neither? I think line symmetry is a lot easier. But if you look, you tell this one is going to have line symmetry. And so you're just saying line, and then you have to say x equals what at this point? This is 0, -1, -2. So it'd be x equals -2. All right. Now this one, do you see how it's not the same on both sides? Like you always want to try to like cut it in half and see like, is the shape the same on both sides kind of? This one is not. If this went up and then down again, then you could look at, does it have symmetry? But this just kind of does this wonky thing here that's not like that. So this one's not going to have any symmetry at all. Okay. But had it gone up and came down, like how this one went down and went up, then it would have. So here, for line symmetry, you'd have to draw a line so that if you fold it, it would fold on to each other. And this one is not going to do that. But if I take this point right there, and I take this and I turn it upside down, you guys, if you can envision this moving, would this move up onto that? Yes. Would this move down onto that? And another way you can check this point, is it the same distance from that to that? And it is. Maybe check that point. That's the same distance to that. So that is point symmetry. So you're going to say point, and then you have to list the point that this is. Now my origin is right here, and it's down 2 from that. So that point would be 0, -2. Now this one, there's no way that I could draw a line that it would map onto itself. Okay. But, and if I took a point, and let's say that I said, okay, let's try to spin it on that point. If I spun this around, it would not map onto itself. If I spun it on this point, it looks like these are hard for me. If you spun it, it would end up going like this. Can you see that? Something like that. If you spun this around, this would end up coming here. This would end up going there. So this has moved. Okay. What you're looking for is if you spin it around, would it map onto itself? And it would not. So then you would just spin it. Okay. Then if we go down here, whenever you have something that like goes and goes down and has this like flattening out, like this one, or like this one kind of flattens out and goes down, that's when you're going to have point symmetry. So it kind of goes down, same on both sides. This one you have to envision is going to come down and keep going. So like this figure here and this figure here are the same pretty much. And so if you spun it on this point right there, okay, you spin it, this is going to go on to here. This is going to go up here. 0. And again, check like, is the tip of this to the point the same as here to the tip of that? And it would be. And this point right here is -2, -2. So this one is going to have point symmetry. And it's at -2, -2. And the point symmetry is always going to be where it kind of flattens out, kind of the middle of that flat point. Now a line does, or I should say a diagonal line does not have line symmetry. So I couldn't draw a line and fold it in half and have this map on. It would have to go up. It would have to be like a V. But this is something you're going to have to remember. When you have a diagonal line, it has point symmetry. And if you spun it on any point that you chose, and you spun it 180 degrees, it would map onto itself. So what you say there is that all of the points have, just say all points. So no matter what point you chose, because a line keeps going forever and ever, if you spun it at 180 degrees, it would map onto itself. So any diagonal line is going to have a point, and it's all points. What do you guys think of this point and kind of envision this keep going? Would it have line or point? Line. And what line would that be at? X equals 1. Did you guys think the points part was hard? So we finished one section and did another, so that's why you have 2 parts. This one doesn't have that many. So that is your assignment. And it looks like you guys have a practice quiz next Wednesday and a quiz next Thursday.